Welcome, everyone. I am absolutely thrilled you're joining me today for this explainer. We're about to unravel a fascinating medical detective story. We're looking at cutting-edge science that connects two completely different parts of your body in ways researchers are literally just starting to figure out. Get ready to look at your internal biology through a totally different lens.
Okay, let's dive into this. It sounds a bit like science fiction, doesn't it? But what if I told you that the scene of the crime for a massive, silent, global liver epidemic isn't actually located in the liver at all? What if the real culprits are operating right in your gut, pulling the strings from afar?
Section 1. The gut-liver connection. Let's identify the victim of our story. We're talking about two very heavy medical terms here, NAFLD and MASLD. But let's strip away all that jargon for a second. In plain English, these are conditions where dangerous amounts of fat build up inside your liver, and importantly, it has absolutely zero to do with drinking alcohol. It's this silent condition, often lacking any symptoms at all in the early stages, but it sets the stage for severe, irreversible organ damage.
Now, for years, doctors treated this purely as a metabolic issue localized right there in the liver and tied to body weight. But here's the massive twist researchers have recently uncovered. The liver isn't acting alone. In fact, it might not even be the primary instigator. The gut is now the prime suspect in the liver's demise. The missing link to this devastating disease is actually hiding in plain sight, right inside your gut microbiome.
Section 2. Global Microbiome Investigations. Here's how scientific detectives around the world are gathering evidence.
31. That number represents the sheer, incredible scale of the research we're drawing from today. We are talking about 31 different global cohorts, with data collected from 2013 all the way through projections into 2026. That's a massive amount of global brainpower working to piece this puzzle together.
And this brilliantly illustrates the global reach of these studies. This isn't just some isolated phenomenon. We have massive clinical investigations tracking the microbiome's role in liver disease spanning decades across countries like Canada, Japan, Spain, Italy, and the USA. It's a true worldwide dragnet. Just to give you an idea of how deep this goes, let's look at one specific massive study out of China involving 1,206 subjects. Think about the depth of that. They aren't just looking at surface-level symptoms, you know? These scientists are deeply analyzing microscopic stool samples and matching them directly against physical liver biopsies to prove definitively what these bacteria are doing.
Section 3. Good bugs and bad bugs. It's time for the lineup to identify our culprits and our missing guards.
Notice the stark contrast here. On one side, we have our enriched suspects, the bad bugs like Escherichia coli, Fusobacterium, and Bacteroides. These guys actively swarm and multiply in the guts of sick patients. But look over at our depleted guards. These are the highly protective good bugs like Faecalibacterium prausnitzii, Ocelospora, and Lachnospora. The real tragedy of this disease is that as the suspects multiply, your essential guards dangerously disappear.
Scientists had to profile an incredibly dense web of these bacterial groups. I'm not going to read through all of this, but just looking at the sheer complexity here shows you exactly how many suspects they had to profile. They managed to map out these complex microbial shifts, pinpointing specific bacterial signatures that correlate directly with a sick liver.
This quote straight from the source material confirms our suspicions perfectly. When researchers look at the gut microbiome of someone with this liver disease, it doesn't just look a little bit off, it's a distinct compositional shift. It fundamentally looks like a compromised security system where the whole environment has been entirely hijacked by inflammatory bacteria.
Section 4. Tracking liver fibrosis. Let's look at the modus operandi and how this escalating damage happens.
Here's the timeline of destruction, the ticking clock of the disease, really. It starts quietly at step 1 with simple steatosis, which is just a fatty liver. Then we move to step 2, NASH, where aggressive inflammation kicks in. Step 3 is fibrosis, graded from F0 to F4, where the liver literally begins scarring over. And finally, step 4, the tragic endpoint of cirrhosis and potentially liver cancer.
To figure out exactly how the gut drives this timeline, investigators stratified patients by their exact disease severity. They matched up specific physical clinical biopsy data from the liver directly with the stool samples. This allowed them to see the precise bacterial shifts happening at the exact moment the liver started to scar.
Now, what's really interesting about this slide is how your body weight completely changes the microbial fingerprint of this crime. Notice how lean NALFD patients actually present with more severe initial fat attenuation and a very specific spike in Escherichia shigella. Contrast that with obese NALSD, which is characterized by a massively reduced overall bacterial diversity and a distinct lactobacillus enrichment. It's two completely different microbial paths leading to the exact same liver damage.
The data backing this up is just absolutely staggering. Look at these specific fibrosis culprits. If your gut is enriched with Fusobacterium, your odds of severe liver scarring jump by 8.66 times. Escherichia shiga, 6.11 times. And if you are simply depleted in that good guard bug, Lachnospira, your risk of severe fibrosis goes up by over 5 times. These microbial profiles correlate positively and directly with physical liver stiffness.
Section 5, Predicting the Damage. We're turning this mountain of evidence into a revolutionary diagnostic tool. So the crucial point is that by feeding all of this complex microbiome and metabolite data into advanced machine learning models, scientists can predict advanced liver disease with breathtaking accuracy. A combined model hidden accuracy score, or area under the curve, of 0.939. In the diagnostic world, that level of precision is an absolute game changer.
Let me highlight exactly why this matters for you, me, and millions of patients worldwide. These microbial gene models mean we might soon be able to detect advanced liver fibrosis entirely non-invasively. Just imagine getting a highly accurate diagnosis of your liver's health from a simple stool sample, completely skipping the need for a painful, invasive, and risky needle biopsy. That is huge.
Section 6, Fecal Transplants and Future Hope. Let's look at potential cures and the ultimate solution to this mystery.
The clinical trial results for fecal microbiota transplantation, or FMT, offer incredible promise. By essentially resetting the gut crime scene, researchers observed significantly reduced fat in the liver and a massive improvement in overall microbial diversity. And remarkably, they saw the greatest clinical efficacy in healing, specifically in those lean NAFLD patients we highlighted earlier.
FMT quite literally replaces the bad guys with the good guys. The treatment restores order to the gut microbiome by repopulating protective bacteria like Bacteroidetes, while simultaneously starving out the pathogenic inflammatory bugs like Proteobacteria. It's exactly like calling in a brand new, highly trained security force to protect the liver and stop the damage in its tracks.
As science continues to map the incredibly complex, microscopic universes inside our microbiomes, the ultimate question we all have to ask ourselves remains: are we feeding our health, or are we feeding our disease? Thank you so much for joining me for this explainer. I really hope this deep dive leaves you fascinated by the power of your own gut health and eager to learn more about the universe living inside you.